Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers. Because once we do, we'll be able to put a donate button and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD and working on a product to help people overcome these problems because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Cece Gerstenbacher. She's an environmental planner, part of the Merrimack Valley Planning Commission. So we're going to talk about her work there. So Cece, thank you for coming.
Yeah, thank you so much for having me. I'm excited to be here.
Yeah, what is your work about? Like, what is an environmental planner and what do you do?
Sure. So excitingly, I've recently been promoted to an environmental program coordinator, but I work for a regional planning agency. So in Massachusetts, we don't have counties in our government system, which means a lot of the planning in the municipal level gets very siloed. You don't find a lot of communities working together. So the state government decided to create these things called regional planning agencies, which kind of take on that county system and act as that regional convener and the folks that bring communities out of their silos and guide them towards some more regional efforts. So I am the environmental program coordinator for the regional planning agency, which takes care of Northeast Massachusetts. And that really means that I have my hands in really every bucket in the environment that I could. I do work from coastal restoration, water quality monitoring, invasive species monitoring, all the way to some pretty high-level project management, grant writing and execution, budget management on things like hazard mitigation plans, municipal vulnerability preparedness plans. I find myself writing bylaws and ordinances for municipalities, deal with stormwater, brownfields, which are dilapidated structures that need to be cleaned up. Either they're contaminated with something, could be petroleum or hazardous material. So I really find myself doing anything in the realm of the environment that Northeast Massachusetts needs. You're kind of a jack of all trades in this position. But the overall goal is to plan for the Merrimack Valley, which is the region that I work in, to get towards that sustainable future where you're considering natural resources, but you also have this sustained and successful growth of the region.
Okay. I guess, do any of the projects involve microplastics? Because I saw that in your bio as well.
Yeah.
So can we talk about that? What's the dynamics of that?
Yeah, definitely. So prior to my involvement in Merrimack Valley Planning Commission, actually working there, I was a collaborating scientist for them in my graduate studies. And that is really where a lot of the microplastic work stemmed from. We do, in the essence of water quality monitoring, one of the things we do monitor in the Merrimack River and all along the Great Marsh, which is the marsh spans Northeast Massachusetts on the coast. we monitor microplastics there in the water column. And historically, for my master's thesis, I monitored microplastics in seagrass ecosystems, both on their plant blades and in the sediments and in the water column all throughout Massachusetts. So that was really ranging from the tip of the Cape in Nantucket Island even, all the way up to the border of New Hampshire. I was doing that.
What were you trying to monitor and model?
Yeah, so back in 2018, people did not even know that microplastics were in seagrass ecosystems. It wasn't really thought of as something that could be a possibility. There was this huge concern around microplastics being in fish and those fish getting eaten and the bioaccumulation of microplastics there. But it was thought that herbivores, like herbivorous fish and other sea critters, were kind of exempt from that. They weren't going to be eating microplastics because they're eating plants. My PI, my principal investigator of my lab in my undergraduate studies, ended up kind of haphazardly identifying microplastics on seagrass plants while she was looking at them under the microscope for something else. It wasn't really intentional, but she was like, what is that on this plant surface? And it ended up being a microplastic. And so since then, it's really been my drive to identify just how many microplastics are in this ecosystem. Where are they in this ecosystem? Are they in the sediments? Are they on the plants? Are they in the water column? What does the flux look like? And is there any particular attributes of a seagrass ecosystem that could make it more vulnerable to microplastics, such as their proximity to anthropogenic impacts? Like if you're a seagrass ecosystem abutting a house or abutting an industrial plant, are you more susceptible to microplastics than this pristine seagrass ecosystem in the middle of the ocean or off of a deserted island or something of that sort? So just trying to figure out, because this is such a new field, even trying to understand where they are and why they're there in the first place and what really causes the changes in their distribution is what I've been focused on the last couple of years.
Yeah, so what are some of the things you've observed?
Yeah, it's been really interesting. One of my preliminary hypotheses was that the more anthropogenic you are, the more the marker I used for that was population density. So the higher the population density near the seagrass ecosystem, the more microplastics you may find in the ecosystem. That was my initial hypothesis. And I had a range of sites. I had 10 sites. Some were really close to Boston. There are abutting houses, there are abutting businesses, and some are off of these deserted islands off the coast of Nantucket where there's no human life for a couple miles. But what was really interesting and kind of concerning is that there was really no difference in the microplastic densities in the sediments, on the seagrass plants themselves, in the water column, among those sites. And that, I feel, really speaks to the pervasive nature of microplastics. They've been around for a long time, and it's only recent that they're really getting the showcase. But ever since plastics were being produced, these microplastics have been getting into our aquatic and our marine systems, which has given them a lot of time to disperse, meaning that they're everywhere. It's not just a concern for urban systems. It's a concern for quote unquote pristine systems where you would think that they're not going to cause that much of an impact. One of the other attributes that I found that was really telling on whether or not there would be microplastics on a seagrass blade is the presence of something called epiphytes. So epiphytes are these tiny little organisms. They can be algae, they can be small sessile animals that adhere to the surface of a seagrass plant, and they make it kind of rough and goopy. Like you imagine a blade of grass naturally is pretty smooth, and it's hard for things to kind of get caught amongst it. But when you have these epiphytes on the plant surface, it makes it rougher. And so the presence or absence or the percent cover of those epiphytes was directly related to how many microplastics you were finding on the plant surface. And what is causing, or at least causing in part, the presence or absence of epiphytes, that is really eutrophication, so the amount of nutrients in the water, because a lot of these epiphytes are algae and they feed off of things like nitrogen and phosphorus, which are being directly input into a lot of waterways by humans. And so sort of in a roundabout way, humans are influencing some of the density differences that I saw amongst the sites.
What about the microplastics? So if microplastics were on certain seagrass, did it cause the epiphytes to come off and, make it inhospitable for them, or did it kill them, or did it encourage more of them to appear?
It's very curious. So one of my questions really was like, okay, these microplastics are on these algae surfaces. These are small single-cell organisms.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Are these microplastics causing any physical obstruction to them? Are they causing chemicals to leach off and harm these epiphytes? And those are really questions that I don't have the answer to yet. We would need to do a study that is not in the field. It would have to be somewhere in a controlled lab setting. You would have to add microplastics to seagrasses with epiphytes and sort of see what the end result would be. But as far as the snapshot, at least that I got when I was looking, you're really only looking at one particular snapshot of time when you're taking a sample from the field and taking it back and examining it under a microscope. The epiphytes and the microplastics were kind of all glommed up together. It didn't really seem from that snapshot that there was anything hindering the photosynthesis of the epiphytes due to the microplastic presence. But that's a real interest of mine. I think that's really where the field, in my opinion, should be heading towards, okay, there's microplastics in this ecosystem. They are right up against these epiphytic communities that can account for over 50% of the ecosystem's photosynthesis and carbon drawdown. What does that mean? Is that important? Are they there not causing any impact at all? Or are they actively harming the epiphytes? Are they actively harming the seagrass blade surface? That's something that just hasn't been explored yet, in part because it's really hard to keep seagrasses in a lab setting. They die pretty easily in a couple weeks. But that's where I would love to see the field go. It's such a new field. Everybody's kind of like, whoa, there's microplastics on seagrasses, and all of the data coming out right now is just sort of saying, hey, there's microplastics here. Hey, there's microplastics here. But the next iteration of that is to say, okay, so what? Does that matter? And if it doesn't matter now, what is the threshold in which it will matter? Like, where does that?
Well, what kind of microplastics are observed? Like fibers or like spheroid particles, or what are you seeing?
In or on the seagrass blade surfaces, we're seeing almost entirely fibers. They are the easiest to get caught amongst the epiphytes. I think spheres are a little bit more difficult to get tangled up in that. And I would really say that's pretty similar in the water column and in the sediments as well. In the sediments, we're seeing a little bit more of fragments, which is just kind of like rectangular or obscure shaped microplastics that aren't necessarily a sphere and aren't necessarily a fiber. But for the most part, fibrous microplastics, we haven't gone through. I'm actually in the middle of conducting chemical analysis on some of the samples to get an understanding of what exactly they're composed of. Are they nylon? Are they polyethylene? So we don't have the results from that yet, but by and large, it's fibrous microplastics finding in these samples.
Where do you think the fibers are coming from? Oh, again, you haven't analyzed, but
the
type of fibers they are. But any idea where they're coming from?
A large part, I would imagine, is probably coming from wastewater treatment plants. So in Massachusetts, and I'm not sure if this is true for other places, but our wastewater treatment plants dump directly into the river during combined sewage overflow events. And even without combined sewage overflow events, they are dumping their technically clean water back into the water system. But a lot of these wastewater treatment plants don't have filters that are small enough, and by a lot, I mean pretty much all, don't have filters that are small enough to filter out these small microplastics. And so you're getting clean water that's not full of all of the nastiness that it would normally be filled of when it goes into a wastewater treatment plant, but they're not really filtering out for microplastics. So I imagine that's probably where a lot of it is coming from in Massachusetts. And they're all over the place. I mean, just thinking about the Merrimack River, we have 4 wastewater treatment plants in that river alone. And they're constantly producing liquid into the Merrimack River. So I imagine that's a large component of it. There's also probably fishing wires and fishing gear in the more open ocean area. But a lot of the plastics, at least in the studies that I've read, are originating in aquatic environments, or originating in like streams and rivers, and sinking in estuarine environments or nearshore systems like seagrass beds.
What about the prevalence? You mentioned that you looked at some remote islands and some seagrass places right next to industry. So what did you notice the difference was?
There was no difference, which is really the disturbing part of that. And we also looked at some seagrass plants in Belize off of an atoll called Turniff Atoll. And there's a huge prevalence. They're ubiquitous as far as my study can tell. And I think a lot of folks around the world are finding that as well. You're doing these studies off of remote islands thinking, okay, there's going to be less of an impact there, but there really isn't. And I think that speaks to the ubiquitous nature of microplastics. I mean, you've got these studies coming out saying they're in deep sea sediments, they're in the Arctic ice, they're everywhere. There's really no marine ecosystem that is safe from them, unfortunately. And I found that a lot of the variances that were between sites was due in part to hydrology and, as I mentioned, the epiphyte cover. So just currents and natural flow of water, and there might be a lull in a current, and there's a higher settling of particulate organic matter when there's a slower current and velocity is decreased. And so there's more microplastics falling out that way. But as far as proximity to industry, proximity to anthropogenic sources, there really wasn't a huge indicator that was impacting, which is very surprising to me, but also a little bit unnerving.
I guess there's enough of them in the water that there's a certain capacity or amount that will stick to the seagrass, and then it floats along and then just goes to areas of lower concentration and starts adhering to those places too.
Yeah, as I've said, they've been around for such a long time. I mean, just because microplastics is this new buzzword now doesn't mean that they weren't in our ocean 20, 30 years ago. So they've had plenty of time to spread out and do their thing and get into these sort of pristine ecosystems that you might not initially think they're in.
I think you'd still have to look at the, what's floating in the water column near the point sources, because there has to be an overabundance of them there.
Yep.
Otherwise, how could they disperse so far?
Yeah, that's actually, so there's a new study that I'm adjacently involved in coming out of UNH, University of New Hampshire, that is looking to take water quality samples right next to these effluents adjacent to the wastewater treatment plants after combined sewage overflow events, or just taking continuous water quality samples near these wastewater treatment plants and trying to see what the concentration of microplastics is right there. There's no data on that yet, at least in Massachusetts. What does the microplastic concentrations look like right outside of wastewater treatment plants versus what are they looking like downstream? How do they disperse?
Well, why don't you, can you clean off, a section of seagrass? Like, let's say there's a point source at, point X, and you clean off some seagrass right near it. And then you go like a mile away, clean off some more seagrass, another mile away. And then over time, over the next few days or weeks, look at the buildup. And that might give you an idea of where it's sourcing, where it's flowing, the rate at which it's accumulating, et cetera.
I think that would work very well in an ideal world where Massachusetts wasn't also seeing a pretty stark decline of seagrasses. So or at least first off, seagrasses are only growing in marine environments, or at least in estuarine conditions. And so upriver, where you've got the wastewater treatment plants, there aren't any seagrasses. And unfortunately, in the Merrimack River, there's been a huge decline in seagrasses over the last, 50 or so years, where there really isn't enough around, or really any around, to do a study like that. There's probably rivers that are more south of myself where you could do something like that. But again, if you clean off the seagrass blade, then you're losing the epiphytes, and those take months to accrue back on. So you might see some sort of altered characteristics due to that. But there needs to be some sort of study like that? Like, what is the accumulation rate? How far away from a wastewater treatment plant do you have to be to directly experience accumulation from its effluents?
Well, if you go out into the ocean, again, if you pick a bunch of radial points, with the hub being, let's say, again, where a river empties out into the ocean, and then you pick, again, a bunch of radial points of different distances, I would guess you could see the dispersion over time. I mean, like you said, you'd be cleaning off the epiphytes, but I mean, have people tried that to clean off the blades of grass and see how long it takes the epiphytes to come back?
Yeah, there's definitely studies about that. I don't know the numbers off the top of my head, but it depends on the nutrient levels in the water and in the sediments, because the epiphytes are primarily algae. I would imagine it also depends on the density, the percent cover of the seagrass system. If you've got a really dense meadow and you clean off one blade, but there's another plant right next to it with epiphytes, they can probably kind of move over to that new plant pretty quickly. But if you have a sparser meadow, it might take a bit longer. And then nutrients, I mean, the more nutrients in the water, the more epiphytes are going to grow and the faster they're going to grow. So that colonization, it wouldn't be overnight. It would probably take, to get up to maximum epiphytic level, it would probably take a couple months. But to start seeing some recruitment, it would probably just take a couple days to a week.
What about the percentage cover or the depth of cover on blades of seagrass? Do you see a lot of variation in the amount of epiphytes and how they cover it?
Yeah, you really do, which is another interesting characteristic to kind of reconcile when you're trying to do a study. Even among sites, I mean, you see maybe you've got a couple square meters of seagrass plants. Just in those couple square meters alone, you can see a couple plants with no epiphytes on them, some plants that are just covered in epiphytes. And that's really where we had to come up with a ranking system for the percent cover, because there was site A has a lot of epiphytes and site B has no epiphytes. You're trying to do a random sample of seagrass blades and you're just kind of closing your eyes and grabbing what you find first. And so you're getting a really wide variety of epiphytes just at an individual site, let alone all of the samples. So we had to come up with kind of a system to differentiate.
Well, why not pick a particular meadow and look at the epiphyte concentration on, adjacent seagrass blades and see what the variation is, and then maybe clean them off and just see how fast the epiphytes come back. And, or you could look at, again, the concentration of epiphytes and correlate that with the concentration of microplastics within a given meadow. There might be a correlation there that you could use then to extrapolate.
So we do have that data, the correlation between the epiphytic cover at a certain site and the amount of microplastics at a site. And that's strong. There's a relationship there for sure. But yeah, accompanying
what's the relationship? More is more?
Yeah, pretty much. There is a statistically significant difference between seagrass blades that have less than 50% cover of epiphytes and more than 50% cover. So once you reach that over 50% cover, and that's just done visually, you are seeing statistically more microplastics on the seagrass blade.
Okay.
Yeah.
But no one understands, why certain blades accumulate more. I don't know if they accumulate at radically different rates. No one's really studied, the accumulation of epiphytes on seagrass, right?
I certainly think they have. I just am not an expert in it enough to speak on it. I think a lot of it may just be happenstance. I mean, whatever's floating by in the water column, that is a juvenile sessile organism that happens to brush past the seagrass blade and adheres to it. Some of it's happenstance in that way. And you've got more common critters that you're finding on epiphytes or on seagrass plants. But I don't know of a study off the top of my head that's done a recruitment study on seagrass plants for epiphytes. I'm positive that it exists somewhere, though, and I'm actually kind of curious about it now.
Okay. I guess, so what are some of the things that you want to figure out again about microplastics going forward? What do you think will be useful, and then what can be done with the knowledge?
Yeah, I mean, I see two pretty clear avenues. Number one is we know that we have this mess in our oceans. How the heck do we clean it up? And how the heck do we prevent it from getting worse? That is something that I think folks a lot smarter than myself will probably have to reconcile. People like engineers who can build these amazing machines that are able to filter out microplastics. That's the end goal here. I mean, there's microplastics everywhere, and they either need to be, the input of them needs to be reduced significantly, which means production of single-use plastic needs to be reduced significantly, or there needs to be some sort of cleanup effort. But I just don't see how. Like, I can't, I mean, I think if I could see how, I'd probably get the Nobel Prize. So I don't think it's crazy to not have an answer to it at this moment, but that's a huge avenue that needs to be pursued and is actively being pursued, but it's hard. It's a hard problem to solve. And then the other aspect of that is really trying to figure out what are the impacts of microplastics in this system and what are the impacts of microplastics in ecosystems in general. My focus being seagrass ecosystems. We know that they're there, but are they actually doing anything bad? Are they just hanging out on seagrass blades like the epiphytes and just kind of doing their thing? Or are they actively leaching chemicals onto seagrass blades and onto epiphytes that is hindering their photosynthesis? Are they physically blocking these seagrass blades from getting light to do photosynthesis? I think those studies need to be done in a lab setting, in a controlled setting where you can have a sort of flume and you've got seagrass plants, you've got their epiphytes on them, and then you can mechanically add microplastics and study the results of that. You can measure photosynthesis, etc. Because we know that they're there, but unless you've got really compelling data that says this is negatively impacting seagrasses, there's not going to be a huge compelling push from a policy standpoint to do something about them. You need data that says like, hey, this is harming this ecosystem. Right. So those are kind of some avenues that I would like to see the science go down. But there's also like you still need continuous monitoring. I think we're not far enough through solving the problem where we don't need to continuously monitor. And that's some of the efforts I am continuing to do, just doing water quality monitoring yearly and getting a baseline for how many microplastics are really in systems. Again, this has only been going on for a couple of years, and so we don't have the same data that we have for things like phosphorus and nitrogen. We don't.
What about creating like a floating raft that would sit in the river? You know, maybe it's anchored to the shore on both sides. It sits in the middle, and then you seed it with these seagrasses, and then you see the accumulation. That, you know.
Yeah, I mean,
do an experiment in the field and have the seagrasses live and get, collect data.
Yeah, they would have to be, the raft would have to probably have like sediment on it and have the seagrasses planted in it in some way. There's also different hydrology at the top of the water column than towards the bottom of the surface. A lot of the reason that microplastics are accumulating on seagrass plants is because of their hydrology. When they're in these dense meadows, they're able to slow down the velocity of water, which causes the increased settlement of particulate organic matter, including microplastics. So that's really why you're getting this huge accumulation. If you were just to pop a couple in the water column, you probably wouldn't see the same effect. But if you were able to replicate, like create a kind of pseudo seagrass ecosystem that you could study in the water column somewhere or somewhere across a river and study in real time the microplastic accumulation on them, that would be an amazing study. I would love to see that.
Well, maybe a submerged raft, like it sits in the bottom, but
you
can take this from the opposite point of view. Like if seagrasses seem to attract a lot of these fibers, maybe deliberately put one or multiple ones in a river.
Yeah.
So then it'll suck up a substantial amount of microplastics, and then the rest of the estuary part won't be as affected as much.
Yeah, that's actually there's been a couple papers or at least thought pieces written on that. Like seagrasses are sinks for microplastics and spinning that in a positive light, saying like they're cleaning up the microplastics. They are reducing the amount of microplastics in the ocean because they are sinking them into their sediments and on their plant surfaces. And the question that I kind of came up with there is like, hey, aren't seagrasses important in and of themselves in producing photosynthesis? Do we really want them to be viewed as just this trash bin for microplastics? They're valuable in and of themselves, but to the extent that you could make new seagrass ecosystems and use them to clean up microplastics, I think that could be valuable. The real technical difficulty there is that seagrasses are incredibly finicky organisms and they don't really like to grow. We've been coupling with this work, doing a lot of just regular seagrass restoration around Massachusetts, and to find a location that they actually like enough to settle and grow out there, it takes years and years. I mean, I've been working in the field for probably 4 and some change years at this point, and we've had one site really take to seagrass settlement, and it's in an estuary. It's far out near the ocean. So finding a site that really works is difficult. You also need to get donor sites, and so you have to take seagrasses from another site and plant them somewhere else, or you have to get seeds from seagrasses and grow them out in the site. So there's lots of complexities with planting seagrasses. I wish it was as easy as planting a lawn, but they're really finicky organisms.
Gotcha.
Yeah.
So what do you think will be figure-outable the next couple of years in this particular area?
Yeah, I mean, I would love to say we'll figure out how to clean up the mess, but I do think that's probably many years away. I do think it's really on the forefront of people's minds these days, microplastics and their impacts in plastics in general. And there's a lot of really cool new science coming out about alternatives, different ways to produce something that is mimicking a single-use plastic. I think that we'll probably see, hopefully, I'm hoping that we'll see some movement on the policy end and on the legislative end that requires some sort of reduction for large industrial practices or large corporations to reduce their plastic production, their single-use plastic production, because, you know, you've got the everyday consumer that's eating a bag of chips and throwing that out in the trash. But then you have huge corporations that are producing plastics by the tons every day. And so those are really where you need to be hit. So I would love to see some sort of legislation that really does make an impact in reducing the amount of plastic pollution that's being produced. And then really thinking about, like, what are the impacts of this? We know that plastics are pretty much everywhere, but before we can kind of get the funds and get the legislative support around cleaning it up, I think we need to show the clear impacts of it. You need real hard data to throw at these people, indisputable data. Otherwise, it's kind of a limp argument. So that's where I would love to see the field go in the next couple of years, and where I will hopefully direct some of my research in the next couple of years.
Okay. Well, very good.
Yeah.
I'd like to have you back, Cece, in the future to talk about all the other projects you're working on.
Yeah.
Put a deep dive into this. What's the best place for people to find out more about your work? Where can they go?
Well, you can certainly go to the Merrimack Valley Planning Commission website. That details really all of my work that I do ever. It's kind of a broad scale thing. You can also read my most recent publication in environmental pollution. That kind of is a thought piece / review on the next steps to take in this field, which is a lot of what we've talked about today, conveniently. And yeah, I'm also on Twitter at CCCC Watt. I will spell that out because it's kind of confusing. It's CECECECEWOT. So you can find me there. And I often talk about seagrasses or repost fun marine biology things there.
Okay.
Cool.
Well, very good.
Yeah.
Well, Cece, thanks so much for coming on the podcast. I appreciate it.
Yeah, no problem.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.